You can go ahead and do it. Stand by.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Good morning, Russell, from the Intrepid. I hope everyone had a restful night. We certainly had a restful night up here, up in the space orbiter. We've been circling around the Earth now for almost 22 hours. We look forward to coming back down to Earth. We want to shout out to Miss Reuter's class for the wonderful wake-up call this morning. It basically, it touched my heart this morning. Let me tell you, boys and girls, tears, little tears. It was phenomenal. Thank you so much for putting that song together for all of us. It got us off on the right foot this morning. All right, boys and girls, we are going to talk about some exercise and how we stay healthy up here up in the space orbiter. Your teachers should have packets for you that have recording sheets that you can utilize at any given time during the lesson or after the lesson. We want to talk about why is exercise so cool. Well, we're up here in the orbiter. We're in an anti-gravity environment, and so we really have to be concerned about how our body reacts not being in gravity. So, one of the things that we have to do on a regular basis is we have to exercise. Astronauts have to exercise 2.5 hours a day just to stay healthy up here, up in the orbiter. 2.5 hours is a really long time if you think about that. And some of the ways that we need to exercise may not necessarily be exactly how you would exercise down on Earth, but we generally will do things to keep our body moving, because if we don't keep our bodies moving, after a while our bones and our muscles actually start to shrink and to break down. Now, if you think about it, I'm already short, and I really don't need to get much shorter. So I really want to make sure that my muscles and my bones are going to stay strong up here on Earth. So one of the things that we do while we're up here is we regulate each other's health statistics. And some of the ways that we do that, we have different equipment that we use. We've been doing it as part of our experiments, but also we do it so we know exactly where we're at and how we're feeling. So we're going to demonstrate some of the different things that we're using to help keep us healthy while we're up here. One of the first pieces of equipment that we use, this is called a peak meter. Now, some of you might actually have seen one of these before. If you have asthma, or if you have problems with breathing, or if you've gone to the doctor and they want to know how much you can breathe the breath out of your lungs, they might utilize one of these pieces of equipment. Now, what we do up here in the shuttle is we utilize this to make sure that our lung capacity is staying very to its optimal capacity. Now, if you look carefully, we have a red zone, a yellow zone, and a green zone. And based on the height of each of the astronauts, we have different measurements. So not every astronaut's going to have the same capacity. But we want to make sure that when we take a breath and measure it, that it's going to be within a range that shows that we're still healthy. Now, Ashwarya, she's going to be our demonstrator today. We have the meter set for her size and capacity, so she's going to demonstrate how we use this piece of equipment. Now, if you notice, she blew into the mouthpiece, and then there's a little meter in there that, for whatever reason, went to the straight top, so she's got some great lung power going right now. We were looking to have a range of 350 liters per millimeter. So right now her lungs are showing that she's very, very healthy up here in the orbiter. Another piece of equipment that you may have seen before if you've gone to the doctor's office, this is called a pulse oximeter. And what this oximeter does, it actually measures how much oxygen is going through your blood, as well as measuring your heartbeat. Whether you know it or not, your finger has a pulse, and that pulse is connected to your heart, and it is showing, how your heart is beating. So what we do is we take our little pulse oximeter, and Lena is going to be our demonstrator for this, and we go ahead and we put it on the finger, and we push the button, and we wait for the oximeter to read her heartbeat and to measure her blood oxygen level. And as you can see right now, her heart is per minute. It kind of what's showing that her blood level, her oxygen level is at 91%. So right now she's got a good amount of oxygen flowing through her veins, and we know that she Another area that we keep measured throughout our mission is making sure that our astronauts are able to see properly. One of the things that happens during the course of our mission is that we get very tired, and we also were in a no-gravity environment, that our eyes and the fluid in our eyes start to flex, and make sure that our eyesight is doing really well. So we have what is called an an eye occluder, and what this does is you cover up your eye, and then we have an eye chart that the astronauts look at and stand at a distance, and Amina's going to use this if you want to turn and show the kids how you cover your eyes. And she looks at the chart, and she looks to see which of the lines she is able to read at a distance. And then we record the information and see over the course of time if that changes, if it stays the same, if her eyesight's getting better, or if it's getting worse. Right now, she's been showing some really good eyesight, so I don't think she's in the need to go to the eye doctor anytime soon. And then last but not least, one of the other things that we do for measuring is do flexibility. And this little machine that we use is called an inclinometer. And what this does is it checks to see how far we can move our muscles from one side to the other. I'm going to have Amina stand here. And what we do is we put the meter up on top of her head, and then we turn there's a little blue line. It might be a little hard to see, but there's some liquid in here. And we measure it up to 0, and then we want to see how far she can tip her neck and her head down to her shoulder. So she's going to tip down to her right shoulder here. And we're looking at the meter. And right now, flexibility-wise, she's got about, good 55 on the flexibility on one side, and then when we have her go for her left side over here, and we tip it the other way, and we look to see how far she can tip down. And she's about 35 on the other side. So right now we know that she's a little more flexible on her right side than she is on her left side. And we would do exercises and stretches to make sure that she can equal out those capacities on each side. Another thing that we do when we are up here on the shuttle is we make sure that we are drinking plenty of water, because with it being anti-gravity, we tend to get dehydrated up here, so we do drink a lot of water. We want to make sure it's in close containers, because in a no-gravity environment, if we open up the bottle, we'd have water globs floating all over our environment. Another thing we do is we do eat our healthy foods and foods that keep our body nourished. We have our MREs. This one is our some beef stroganoff. We do treat ourselves a little bit, because if you exercise, you should every now and then give yourself a little treat. So we do have some astronaut ice cream that we brought with us up into the orbiter, and we've all enjoyed some of that last night. And then we fresh fruits and that we are able to keep with us. They're dehydrated, and we just rehydrate them and utilize them in our foods. We had some blueberries with our breakfast this morning. So those are some ways that we keep healthy. Right now, what I'd like for all of us to do is we're going to participate in some of the exercises that the astronauts actually do in the space orbiter. Just a side trivia before we get started. Did you know in the International Space Station that the American astronauts do not exercise the same as the Russian astronauts? Now, I'm not exactly sure. I hadn't had a chance to research what the Russian astronauts do, but I thought that was kind of interesting that they're all together in the same place in space, but yet they're not going to exercise the same. So that's just a little culture connection there that I thought you guys might like to know. So if you all can find a space where you're not touching your neighbor, and you're not going to run into the furniture. And make sure your teacher knows that you're in a safe place. I'd like for you to participate with us. There are three main exercises that astronauts do when they are on the space shuttle. The first one that they do is they use a special egometer and hygrometer, and the cycle is a special bicycle. Now, in order to do this exercise, since we do not have the actual hygrometer here, we are going to simulate the bicycle. So what you need to do, you kind of have to get on your back like a turtle, and then you're going to put your arms to your sides, and you're going to put your feet up in the air. Make sure your feet are not touching your neighbor and are not going to kick anything, and we're going to pretend, and we're going to cycle into the air for a few minutes. So let's everyone get ready. All right, I hope everybody's ready. All right, everyone starts cycling. We got to get those legs moving, get our heart rate up a little bit, muscles going. All right, you guys are doing a great job. Keep it up. We're almost ready to change. All right, keep it going. Okay, and we're going to stop in 3, 2, 1, and stop your legs. All right, carefully sit up. I need you to stand up. All right, that's one of the 3 type exercises that the astronauts do up in the orbiter. Another one that they do is they actually use a treadmill. So we are going to sit on the treadmill. So let's get ready to jog. Stand up. Make sure again you are not in your neighbor's space, and you're not going to run into the. And you're going to jog in place. In place. You're not moving around the room. Just so you know. All right, let's get ready. 5, 4, 3, 2, 1, and jog. Keep jogging, keep moving, get that heart rate up. Okay, we're almost done. All right, 5, 4, 3, 2, 1, and stop. All right, some of the other ones that we do is it's called resistance training and using armbands, but we're going to stretch our muscles. So put your feet apart, and we're going to touch our toes in a cross windmill position. So let's get ready, get set, and go. We're going to go to 20. All right. Now, as they use a astronaut, and the plate will jump up and down. So we're going to simulate that. It kind of like, and you can do this too. It's like walking like a penguin, but you're not going anywhere. So we're going to do that for 30 seconds. Keep it up. Keep it going. Gotta get those muscles. Don't want to lose any bones. Don't want to get any shorter. stop. Right. Now, last but not least, we're just going to add one more exercise here, just to get our bones and our bodies going. We're going to add 10 jumping jacks to finish this off. So let's get ready. 3, 2, 1. All right, boys and girls, if you have been doing our exercises, you should be feeling a little bit out of breath. You should be feeling your heart pumping a little bit harder, and definitely you will know that you're not going to lose any bone or muscle while you're up in outer space. All right, with that, on your packets, a challenge, and this challenge goes out to every classroom in Russell. Has a little, like the Steiner carries a little Fitbit on her pocket all the time, or your teacher has one on her watch, or she might have one on her phone. We would like to see which walks the most or takes the most steps in one day. So, let's do this. Monday morning, starting straight off from when your teacher gets out of their car, have your teacher start the meter. On your sheet, make a prediction about how many steps you think your class is going to take in a day. Then, starting with your teacher getting out of the car to when we get ready for announcements right at 1:50. That's where you'll stop. Have your teacher record the number your class took. Make sure they put their name to it, and then send it on into Miss Steiner's mailbox. I'll calculate all that stuff. Nobody has to worry about regulating that. And then we'll see which class is making the most distance in the most day and getting some of the most exercise throughout the whole day. All right, Russell. This is the end of our primary lesson, but we have a real special presentation that we would like to do prior to changing to our question and answer session. So, come on over, boys and girls. All right, if we can have Mr. Laster paying attention to the camera lesson, if anyone sees him, make sure he's looking at the camera. And I'm going to have, Amina is going to be the first, and she's got something special to say.
Dear Mr. Laster, you are the strongest teacher I've ever met. When I say strongest, I don't mean arm muscle. What I mean is that you carry us through tough times. You reminded us who we are and who we stand for when we are slacking on something. You believe in us, when we missed a whole week's worth of valuable training, but we kept through it with our chins high. You were very trustworthy because you canceled practice the day before the launch because you knew that if we missed one day before the launch, you might. And for 10 years, you have us things. Right, not exactly things, but tough and competent. Everyone who's ever worked with you on space team, responsibility, respectfulness, and many other things that they will carry throughout their life. Even people that weren't on the space team for the whole entire time will learn life lessons. Godspeed, Amina Turkovich, MS-1, Badger, and the first EVA astronaut.
Thank you. Means a lot, guys.
Dear Mr. Laster, I appreciate everything you've ever done for us. As an astronaut, I know how many obstacles are on one mission, and since you've just accomplished 10 missions that were successful, I know how much hard work you've done for the crew and mission control. part of the astronaut crew and mission control, you changed every kid that has worked on the Russell Space Team with you. You have taught us life lessons. Like the unexpected, and no matter how hard things are, we are nothing except for tough and competent. I will through the rest of my life. Thank you, Mr. Laster. Ashwarya.
Thank you, Ashwarya.
Dear Mr. Laster, thank you for all that you do for the Russell Space Team. You take your personal time off for us. In addition, the first EVA was a success because we had all the supplies that we needed to complete it because of you. By the way, thank you for teaching all of us the right way to stay calm and problems. In fact, you have taken off 10 years for the Russell Space Team and 275 hours when we did launch and landing for all 10 missions, as it was years. But we didn't even count the training yet for all 10 years. 280 weeks. In conclusion, the Russell Space Team and I am very thankful for all that you do for us. Good luck. Love, Lena. MS2 Panda.
Thank you, Lena.
Mr. Laster, thank you so much for all of your dedication to this program. You've been doing this for a long time. You've been doing it for 10 years and over 275 hours of missions.
Thank you, Jameson.
Dear Chris, a.k.a. Mr. Laster, decades that have passed up and challenges they've never known they could accomplish, only of such a great facilitator. This program has inspired students to go out into the world knowing that they can do anything. Thank you for all you do, and I am, as a co-worker, most of all a friend. One day, the reality of us really being able to experience space will happen, but until then, this is the next best thing outside of NASA. Best always, MS3, Miss Steiner. Russell, I'm going to give Mr. Laster the loudest round of applause to give him.
Thank you, Miss Steiner.
All right, we are going to prepare for our question and answer session. Want us to just go right straight into the question now?
Yeah, just whatever you guys feel like you have time to do. We can do questions at the press conference too. Yeah, go ahead and do the video tour.
I'm also the commander, and I'm the first officer. And I'm going to the mid-deck. This is where we don't do the controlling of the shuttle, but we do stuff here that doesn't involve controlling the shuttle. So over here we have the bunks, over here and over here. This is where the astronauts sleep. It's basically just a sleeping bag and then another pad under it. The bottom bunks have 2 pads, and so all the astronauts basically just sleep on a bunk, and they choose whatever they want. Space, you sleep vertically attached to a wall, and you're strapped in your own compartment, so nothing else floats away, like you. Over here is where we contain our food, also called a galley. This is our microwave and our little fridge that we have, and other food items that don't need to be refrigerated. Over here, you can kind of see our health supplies, but also the sink where we do have running water. Over here is the airlock that we use for the evening. And over here we have storage units. That's where everything goes that all the astronauts have, what we need for experiments. The bottom 2 rows are for astronauts only, and that's where you keep all your gear and whatever your personal stowage is. The top 3 rows over here are for experiments that we need or any extra supplies. Over here are the oil canisters right here. This is for your filtration and air that makes sure that it takes out all the carbon dioxide that you don't need. So every few hours you change canisters. The canisters look like this one. So you take out an old one and you put a new one in here every time you need to change them out. Okay, so here we have our airlock, which is when we stay in for about 2 hours getting suited up, and this is where we put our helmet, and our helmets are right here. So here we have our helmet and our skull cap. Our goes with our helmet inside of it. T-shape on the locking the skull cap so that it fits in with the helmet, and we connect this with the O2 umbilical cord so that visor on the helmet. That oxygen, we can breathe through it and we won't fog up or die. And then we have our locking collar, which connects to our helmet, and it's right here. And all you have to do is just lock it and tuck in the bib, which is right here. And then we have our pack, which has all stirred up things in here. white suit that goes over our over our uniforms. This is from the space atmosphere, and we have gloves, we have belts, and special boots, which look like this.
Last night we went out EVA. Well, we had our first task, and we, as I was, it looked like this. So we like if we like start to touch it and screw it over as I was apart, it would, never mind. We're going to bring it back to Earth with us. Now we're moving on to flight deck.
Guys, we lost your video. No, we got it back. We got it back.
Time. So this is the flight deck. This is launch and landing. This is where we stay. This is CDRs. This is commander seat. This is pilot. This is MS2 seat. And this is MS1 seat. MS1 is in charge of the GP general purpose computer, and the general purpose computer is in charge of some of the things that goes on the mission. They can input numbers, letters, different input. And MS2 is in charge of, commander has switches and along with, and they have panels, R1, R2, L1, L2, O3, O1, O2, O3, O6, O7, O8, F8, F6, and C3. I think that's all. And we flip these switches during launch and landing, but we have some during, like when we're just walking around in orbit. And we flip the switches with our procedures, and they tell us which switches to flip. And MS2 is in charge of ATLs, which are attitude timelines. And attitude timelines change where the orbiter is facing. There's the roll, pitch, and yaw, and they change how the orbiter is facing. It could be upside down, sideways, or like backwards in orbit. And right now our pitch is 270 degrees, and 360 degrees is like it's 0. So these are 360 degrees, both of them, because they're at 0. And we have 2 seats with other seats. MS3 and MS4 sit here, and Miss Steiner, which is the teacher in space, is MS3 this year, and she's in charge of the experiment in space. We've gone to the mid deck. getting and well, the first question is from Miss Bodner, and it is, what was the hardest job you had to do on the mission? Well, the hardest job I had to do was the EVA comm, which is over here. This is the station that I worked at while Badger and Panda were doing the EVA. I worked over here, and what was hardest for me was we would switch them from the 80-20% that we breathe on Earth to 100% oxygen so they can go in space. The computer kept having a malfunction, and it kept going back to 80-20 when the airlock was already on 100%. So it was kind of hard to deal with, but we got through it. Next question is from Miss Johnson's class. It is, how do you sleep in space? Well, like I said before, these are the bunks that we did use, and in space you do sleep on the wall, or sometimes in like this little room compartment where it's just big enough for you, and you strap yourself on, and then you basically go to sleep in a sleeping bag that's kind of standing up. And the last question is, what are some experiments that you do in space? Some experiments that you do in space were demonstrated already, like oxygen saturation, where this thing takes your oxygen level. And we took this magnifying glass and you put it on top of your eyes like this. For sleep deprivation, and you walk across a line while holding this on your eyes, and then you turn around and you stand there, and then while you can't see anything, someone tries to throw an object at you and you have to catch it. Then last you have to come over here to the board and you write your name without looking. If you get all of them, you pass sleep deprivation. We will answer further questions at the press conference.
Hey guys, those were awesome lessons. We're going to go ahead and switch back over to AGL1, and we'll get on with the business of landing. So.
See you in a few hours.